Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these exponential functions. So let's start with the first one. If f and x equals 1 over 3 parentheses e to the power 3x plus e to the power negative 3x, find prime of f at 1. That means we have to find the derivative of this function at x equals 1. So the first step is to find the derivative of this function f of x. Now this function is made up of the coefficient 1 over 3 times the expression in the parentheses. So the coefficient 1 over 3 will stay the same. So prime of f of x 1 over 3 and then parentheses. Now we have to find the derivative of the exponential terms in the parentheses. So for the first term, so the derivative will be the given exponential term, which is e exponent 3x times the derivative of the exponent. Now the exponent here is 3x and the derivative of 3x is just 3. Because 3 is the coefficient, so it will stay as it is, and the derivative of x is 1. And then plus. So in the second term, so there's an exponential term. So the derivative will be the exponential term itself because the base is e times the derivative of the exponent. Now the exponent is negative 3x. So the derivative will be negative 3. So the coefficient will stay the same times the derivative of x, which is 1. And now we can close the outer parentheses. Now we can simplify this expression. So 1 over 3 and then parentheses. So in the first part, 3 times 1 is 3. So we'll just get 3 e to the power 3x. And in the second part, so we multiply negative 3 by 1. So we get negative 3 and then e to the power negative 3x. And close the parentheses. Now we have to find the derivative at x equals 1. So in the next step, we can sub in x is 1 equals 1 over 3 and then parentheses. So 3 and then e exponent 3 times 1 minus 3 and then e negative 3 times 1. Now we can simplify this expression. Prime of f at 1 equals 1 over 3. So in the first part, in the parentheses, in the exponent, 3 times 1 is just 3. So we get 3 e to the power 3 minus 3 and then e to the power negative 3. Now we can factor out the 3 from the two terms in the parentheses. So we get prime of f at 1 equals 1 over 3 times 3 and then e to the power 3 minus e to the power negative 3. Now at the beginning of this expression, so the 1 over 3 times 3 is equal to 1. So the coefficient is 1 and we don't write the 1 as a coefficient. So we just write e to the power 3 minus e to the power negative 3. So this can be the final answer for the derivative of the given function at x equals 1. But if we want to make the exponent, the second exponent positive, we can move that term to the denominator. So the final answer can also be e to the power 3 minus 1 over e to the power 3. It is a good idea to show all exponents as positive exponents in the final answer. So this can be the final answer for the first function. Now we can find the derivative of the Second function, f at x equals e to the power negative 1 over x plus 1. Now in this given function, the exponent of e is a fraction. Now in order to make it easier to find the derivative of this function, we should move the x plus 1 to the numerator, and that will make its exponent negative. So first step is to rewrite the given function as f at x equals e, then minus, and then x plus 1, the exponent negative 1. Now we can find the derivative of this function. So prime of f at x. So this is the exponential term with the base e. So the derivative is the exponential term itself as it is given, times the derivative of the exponent of e. So we do minus, so that's the negative sign in front of the parentheses. Now here we'll have to use the chain rule, because the exponent has an inner function x plus 1 and the outer function is the exponential function with the exponent negative 1. So we start with the derivative of the outer function. So the outer function is the exponential function with the exponent negative 1. So we can use the power rule. So minus and negative 1 times the negative, so then x plus 1, and we subtract 1 from the exponent, times the derivative of the inner function, and the inner function is x plus 1. So the derivative of x plus 1 is 1 plus 0. Now we can simplify this expression. So prime of f at x equals, then the first term stays the same, times, now minus negative 1 is equal to positive 1, and then we'll multiply it by x plus 1, and in the exponent minus 1 minus 1 becomes negative 2, so we get x plus 1 exponent negative 2, and then in the parentheses 1 plus 0 is just 1, and multiplication by 1 doesn't change anything. Now we can make the exponents on the terms positive. So prime of f at x, so e, and then negative 1 over x plus 1 times 1 over x plus 1 squared. Now we have to find the value of the derivative at x equals 0, so we can sub in x as 0. 0 plus 1 times 1 over 0 plus 1 squared. Now we can simplify this expression. So prime of f at 0. So in the first term, so in the exponent and the denominator, 0 plus 1 is 1 and negative 1 over 1 will be just negative 1 times. Now in the denominator, 0 plus 1 is 1 and 1 square is 1 and 1 over 1 will just be 1. So we can rewrite this as, so prime of f at 0 equals e to the power negative 1, which can be changed to 1 over e. So in the final answer, we should not keep a negative exponent. So this should be the final answer for the derivative of the second function at x equals 0. Now we can analyze the third function. So h at z. Now h at z is made up of two functions. One is the z square, which is a polynomial function, times the expression in the parentheses, which has the exponential term e to the power negative z. So for this function, we should use the product rule to find the derivative. So we start with the derivative of the first term, z square, and the derivative of z square is 2z. as per the power rule times the second term, so 1 plus and then plus the first term, which is z squared, times the derivative of the expression in the parentheses. Now derivative of 1 is 0 because 1 is a constant, and then plus. So the derivative of this exponential term with base e will be the term itself with the base e times the derivative of the exponent, which will be -1. Now we can simplify this expression. So in the first part, so we can move the e to the power -z to the denominator to make the exponent positive. So it will be 2z times 1 plus 1 over e exponent z plus. Now in the second part, so in the parentheses, 0 will go away, and then e to the power -z times -1 will become then minus e exponent -z. Now we can move the e to the power -z to the denominator to make the exponent positive. So one thing we have to keep in mind is in order to evaluate terms, the exponent in the term should be positive. So in the next step, we get prime of z equals 2z plus 1 over e exponent z plus z squared times -1 over e exponent z. Now we can sub in z as -1 in this expression. So prime of h -1 equals, so 2 times -1 times 1 plus 1 over e exponent -1 plus -1 squared times -1 over e exponent -1. Now we can simplify it further. Prime of h at -1. So 2 times -1 is -2. Parentheses. Now the e in the denominator has a negative exponent, so we can move it to the top to make it a positive exponent. And in the second part, -1 square is +1, and +1 times negative fraction will give us a negative result. So -1 over e exponent -1. Now in the first part, we can distribute the -2 in the parentheses. So we get prime of h -1 equals -2 minus 2e. And now in the fraction, we can move the e term to the numerator to make it a positive exponent, so minus e to the power 1 or just e. And now we can combine the e terms. So I got -2 minus 3e. So let's fix that. So this should be the final answer for the derivative of this third function at z equals -1. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.